Hi, my name is Dia Akmal bin Ibrahim, and this is a video presentation for our project. So this video will be presented by Dia Akmal bin Ibrahim, which is me, and my partner Nurul Hasanah binti Muhammad Yusuf. Our team ID is MY133, and our course is Bachelor of Electronic Engineering. Our supervisor is Professor Maria Dr. Lokman Hanif bin Muhammad Auda, and our track for this project is Cloud, Web, and Mobile App Design.
Problem statement. Hydroponics is forward as a solution to combat climate change, to reduce the environmental damage and species extinction. It also allows for a more rational use of water. However, hydroponics garden may contain different varieties of plants, and different plants require different nutrient solution concentration for growth. Plants' ability in a hydroponic garden to absorb nutrient solution depends on the pH of the nutrient solution. Next, current solution and its limitation. For solution, TDS meter. TDS meter is a small handheld device used to indicate the total dissolved solid in a solution. pH meter. A pH meter is a device used to measure acidity or alkalinity of a solution. For limitation, TDS level and pH level to be monitored from time to time. Water in the reservoir tank needs to be physically monitored. Temperature of the water also needs to be measured from time to time. Our solution. Hydroponic monitoring system will measure the pH level, TDS level, water level, and also temperature. It can be monitored through any electronic device. Why is better? Provide hydroponic real-time monitoring system measurement data that can be accessed from anywhere via the internet.
Next, we go to the demo and user feedback, which is we ask for 5 questions to the user. Question number 1 is how easy was it to set up and install the monitoring system in your hydroponic setup? And the question is ranked from number 1, very easy, to number 5, very difficult. As we can see, there's a majority of user vote for number 3, which is like it's not too easy and not too difficult. And 9 user answer for number 1, and only 1 user answer for number 5, which is very difficult. The next question is, will the user interface easy to navigate? This question is also ranked from number 1, very easy, to number 5, very difficult. So majority of the users say it's very easy, which is number 1, and only 1 user say it's very difficult. Okay, and the next question is question 3. Did the monitoring system provide a reliability data on parameters such as pH level, TDS level, temperature, and water levels? So this the question have 3 answers, which is yes, no, and I don't know. So according to the pie chart, we can see 86.7% users say yes, and only 13.3% say no. It say I don't know. And question 4 is, did the monitoring system contribute to improve efficiency in resource utilization such as water? And the user 80% of the users says yes, and only 20% of users say maybe. And question 5, overall, how satisfied are you with the performance and functionality of the monitoring system for your hydroponic? So there's 9 people say very satisfied, and only several people, only 1%, only 1 user say not satisfied.
Target segment. The target segment for a monitoring system for hydroponic will primarily be hydroponic growers, whether they are small-scale home growers, commercial greenhouse operators, or agriculture enterprise specializing in hydroponic cultivation. Impact. Monitoring systems for hydroponics offer improved efficiency, crop health, resource management, and data-driven decision-making. This impact can benefit hydroponic growers by enhancing their operation, increasing yields, and promoting sustainable practice. Okay, for the design research methodology, as you can see, this is the software that we use for this system, which is Arduino. Secondly, is Blink. So for the hardware initiation, we use waterproof temperature sensor DS18B20, which is used to for measuring water temperature. Second, we use TDS sensor. TDS sensor used to indicate the total dissolved solid in a solution, usually water. Third, we use pH sensor, help to measure the acidity or alkalinity of the water. Fourth, we use HCRS04 ultrasonic sensor used to determine the distance to the water. And lastly, we use ESP32 cam Wi-Fi plus Bluetooth used to capture picture of plant over time. Okay, for the block diagram, as you can see, the input is the sensor, which is TDS sensor, pH sensor, temperature sensor, ultrasonic sensor, and ESP32 camera. And for the microcontroller, we use ESP32 microcontroller, and the output is Blink and any device and any electronic device. Technique. The hydroponic system that has been used in this project is deep flow technique, DFT.
Now we go to the result and discussion part. So the first result is for temperature level. So the temperature of the water affects the dissolved oxygen levels in the hydroponic system. The figure shows the reading of temperature around 27 to 31 degrees from the Blink dashboard. The ideal water temperature in hydroponic varies depending on the specific plant species being grown. As for the project, the ideal range of water temperature in our hydroponic system is 18 to 30 degrees. Okay, and next we go to the next result, which is a water level. So figure shows the result of the water level from Blink dashboard. As the hydroponic system is typically open to the surrounding environment, water can evaporate over time. This particularly true if the system is in a warm and dry environment. Plants also absorb water and nutrients through their roots, and it leads to the decreasing of the water in the reservoir tanks. To maintain the appropriate water level in hydroponics, it's important to monitor it regularly and make adjustments as needed. So the next result is pH level. So the figure shows the result for pH level from the Blink. This nutrient solution needs to maintain a specific pH range to ensure optimal nutrient uptake by the plant. So in this project, we use pH range for hydroponic system is around 5.5 to 6.5. To maintain this desired pH level, we use pH up and pH down. Next is TDS level. The result also display the real-time data of TDS sensor. So the concentration of dissolved substance, including minerals and nutrients in the water, is typically measured in parts per million, which is ppm. For seedling, only require a ppm reading of 400 to 700 ppm only. And for our seedling, we use 400 to 600, which is our seedling is water spinach. So the ppm level shows in the reading is around 700 ppm. The ppm level in the water can indeed decrease in the hydroponic system due to plant uptake. Okay, next we go to the project demo. And last, we go to the conclusion part. So, hydroponic monitoring system using IoT is a system that provides a real-time update of the data that have been measured by using both hardware and software application. It could help to monitor the level of water in the reservoir tank, temperature, level of pH, and also level of TDS in the water. This system is being introduced to help monitor the supply of nutrients and also to ensure the plant is in optimum conditions. That's all from us. Thank you.